Hello. Priyanka, are you a regular student of NPTEL?
Yes, yes.
Okay, okay. So today is the last session. So today we are going to solve some numerical problems
Okay.
based on the overall thing and some of the assignment problems. So I'll start presenting my screen and start this. Please stop me if you can't hear anything or if you have any doubt.
Okay.
Okay. So let's start. So this is the week 10 assignment problems. Did you solve it? Yes. I think the solution is already there. So these are based on hybridization and some other problems. Did you solve it? Hello?
Hello. Yes.
Yes, acha, okay, okay. So we'll just solve it one by one.
Okay.
So the first question is in sp3 hybridization, the contribution of so the question actually says that what is the contribution of S and what is the contribution of P,
Yes.
and from these let me give you a hint that in exams also, in NPTEL exams also, when they are asking multiple correct answers are there, the option is actually the cubical answer. So it is possible that there are multiple correct answer is there, and when the points are in circular form, there is only and that is MCQ, and only one answer is correct. So the, as you can see, for the first one there are square shaped options are there, so there are multiple correct answer is there. Obviously the first one is incorrect, right? That each of the px, py and pz orbital is necessarily 25%. That is not the case. The
No.
total p orbital should be 75%.
Yeah.
So the third option is correct
Third.
and second option
Second.
is correct.
Yeah. Yeah.
Yes. And pz orbital is 0. Obviously if c is correct, then d is incorrect.
Yes.
Now the second question is, if the bond angle is 105 degree and hybridization involved SPX, then what? So from the previous knowledge we know that if it is sp2, then the bond angle is 120 degree, right? Like bf3, this kind of planar molecule, right? So if x is 2, then you know that the angle is 120 degree. Now you know for tetrahedral, or you can say like for methane, sp3 hybridization, there the angle is 109 degree, right? 109.4 something, right? 109 degree, and it is even lesser in this case, which is 105 degree. And one thing is there, when the p character is 100%, actually when there is no s character would be there, so that time the angle is 90 degree. So it is between 4 sorry, it is between you can say uh, what I am trying to say, if it was totally p character, then it was 90%, 90 degree, the angle would have been 90 degree. But it is at least it is greater than 3, because
Yeah.
for 3 the
Between
angle,
3 and 4.
no, actually for 4 also you can't say, because for 4 sp4 means the p character is 80%
Mm.
and s character is 20%, right?
Yes. Yes.
But in case of sp4 also, the previous, I think the previous day I have solved for that, means Sarah has also solved in the lecture series also, that non-equivalent hybrid orbitals for water. So
Yes.
you
Yes.
will
Yes.
see that the bonding hybrid orbitals have sp4 character there, and the
Yes.
angle was mentioned around this 105 degree. So it is actually, this x is actually around 4 here, not less than 4. So
Okay.
the actual answer would be, in this case, would have been x greater than 3.
3.
It could be anything greater than greater than 3. But you remember one thing, when there is nothing there, when there is s character is 0% and p character is 100%, then that is not a hybridization, right? Because sp mixing is not there yet. So that in that case, it is the angle would have been 90 degree. So that is one point. So this is already solved for two, so for question number 2. Now question number 3, hybrid orbitals are there are four options out of these highly directional, right? So, and because of that only we invoke sometimes them in the molecular orbital theory also. Like I think you have seen the molecular orbital diagram for carbon monoxide, right? Where hybridization was involved inside the MOT. So, अच्छा, ये Priyanka, at which means are you finished with the lecture series or means the week 12 also, or
I have finished, but I have to submit the assignment of lecture this 12 week 12. I have not submitted the assignment. Today
okay?
is the last day, na? Today,
Yes.
tomorrow. Tomorrow, I
I think
think.
tomorrow. I think tomorrow.
Yeah, tomorrow,
But
yeah.
you check also that if it is today or not.
Yes.
Okay. So
And sir, how do we know, like, our score for the assignments?
um, that I actually don't know. I'll ask some of the coordinators and I'll inform that into the discussion forum, or maybe um, how can I tell you? Maybe the in the YouTube comment link I will post it, or maybe in the discussion forum the mail will go to you. I
Okay.
think they will let you know actually.
And what about exams? Like, they've not told us the centers or the hall tickets.
Okay, so you have registered for the exam, right?
Yes, right from the day I had registered for the course, I had registered for the exams, but I have not got any details
Okay,
after that.
I think they will share the admit cards. In which city are you in?
I'm in Goa,
Okay, okay.
so, so
Then
I don't even know whether it's a center. So that's the reason I just wanted,
okay,
you
okay,
know.
okay. I have to check actually. I'm not sure of that. If you are in West Bengal, then I would have said that the center would have been in Kolkata maybe.
Okay.
Or maybe in Maharashtra, then maybe Mumbai or Pune.
Hmm.
But for Goa, I'm not sure. I have to see. And
Okay.
I think it would have been already there in the maybe portal, or you can check in the Swayam portal that where are the exam cities for other courses also. Then
Okay.
we would have got idea.
Okay. I'll do that.
Okay. And no, sir, please. Only Orko.
Okay. Okay.
I'm very
Okay.
senior, I guess.
Yeah.
Okay, so question number 4. So for a SPX hybrid orbital, the psi is given where individual contribution coefficients are given for each, and I hope this is normalized. So in questions they may give something which is not normalized. Okay, so it is better to always check if it is normalized or not. You know that each of the hybrid orbital is orthonormal, right? Because it will be orthogonal to other hybrid orbitals and will be normalized to the other to itself, right? So you should always check the normalization condition. For this case I guess it is I should not guess, let me calculate at least in my mobile, which is 0.625 square plus square into 2 maybe, because there are two terms.
No, only a peak percentage they've asked, no?
Yes, but before that you
Ah,
should
okay.
also
Okay.
check if it is normalized or not, else you will get a wrong answer. So actually the square of all the terms is coming around 1.05, which you can take as 1. Okay, so it is fairly normalized. And so for p orbital, so what do you prefer? So how do you would proceed from here? So you know this is normalized, then how would you proceed for the percentage of p contribution for this question? What do you think?
Square the coefficient, this, no?
And get the
0.31.
sum, and get the sum, right?
Yes, and get the
But
sum.
that would be tedious actually. So you can do for this question that get the contribution for s minus it from 1.
Yes, yes. Minus from 100.
Okay.
Yeah.
So I'm not going to the value, but this is the
0.66 is the answer.
yes, then it would have been. I am not sure about the answer. Yeah, 0.62 square would be around 0.4, 0.44, 0.36, because zero point 0.6 square 0.36. Then yeah, 1 minus 0.36 is 64 or 66 as you said, maybe. Yes. So for the, then let us go to the question number 5, which is here. I have kept here. For the sigma overlap of a 2s and 2p orbital, the plot of the overlap integral against the internuclear separation. First let me draw 2s. 2s, so I'll draw, so there will be a radial node, right? So this is, maybe I can keep this thing plus, this is minus, and 2p is just this double shape. Let me take this side minus, this side plus. So if it is overlapping, so what is going to happen at r equals to 0 means two nuclei are overlapped. So at that position, so this is minus plus, inside this is plus, which is obviously is going to be 0, right, for both the overlaps, and there is minus. So outside the outer lobe, that is also going to be 0, right? if you if we check one by one, two lobes, right, means this is means what, this we're just checking the integration, right? So this side is minus, this side is plus. So if you are using anything spherical inside, so that would have equal effect from both the lobes. So minus will means I hope you are understanding what I'm trying to say. So the at r equals to 0, the overlap is going to be 0, right? So this is one of the correct answer. And they are saying if, and the another answer would have been that is not negative for any value of r. In case of antibonding, the overlap is negative, but here as we are sigma overlap is mostly we are talking about the bonding. That is why this is not negative for any values of r. Okay, so I think in the previous video lecture also I have shown a few emotes, how the overlap would look, the overlap integral SAB would look, the plot of that with R. So if you think of a S, and suppose you are thinking of two p orbitals around, suppose they're sigma bonding, right? So this is the internuclear axis, that which is mostly considered as Z. You can consider it as X also, no problem, but then the others will change. So if this is plus, uh, this is plus, this is minus, then what is going to happen? um, so they are going to small positive lobe and two big, one big positive lobe and one minus, right, like this. So when they are top of each other, see, then the, so when it is top of another, when internuclear distance is 0, means the two nuclei is in top of each other, two, then r is 0. So at 0 you see the overlap is also 0, plus is with minus and plus is minus, so overlap is 0. But at certain distance it is increasing, right? At when this will form, right, this is at that distance where the overlap is maximum, and then again when the you are uh, increasing the internuclear distance, then again it will fall like this, and at infinite distance or at some distance it will be 0. I hope this point is clear, I hope so. Is it so? You have some doubt?
Actually, I have a doubt. I did not understand this concept very well about this R,
Okay.
the,
So
the problem 5 also.
yeah, so it is talking about the MOT theory. For MOT, what do you take? For MOT, you have to means synthesis something. Synthesis means you have to take a linear combination of atomic orbitals, right? Which is LCAO model or approximation. Linear combination of atomic orbitals. So there are two considerations. Means two. Means you have to consider two things. One, that the atomic orbitals have to be energetically similar. I am not saying same, because obviously 2s and 2p may not have the same energy. Means if you say that both are n equals to 2 and energy of those orbital is the same, even if they are not same, you have seen for so I am actually diluting the thing, I am going here and there. Let me come straight that suppose uh, for LCO model, you have to choose two orbitals or more than two orbitals where orbitals are energetically similar and there is some symmetrically matching is there. Okay, then only you can form that linear combination of atomic orbital. If there is no matching, then you can't form a bond. Okay, so which means uh, here see 2s and 2p orbital there is some symmetry matching, because this minus and minus if they are coming towards, then they will form some bonds, right? And energetically 2s and 2p may have some are almost close to each other. If suppose we are considering two homonuclear atoms, is it making sense?
Yes, yes, yes.
Yes. So then you are what you are doing, that at space you are closing the distance, means you are means two of the atoms are coming closer. Okay, two of the atoms are coming closer, one of 2s and another of 2p. Then it will form some bonding type, right? This minus minus they will overlap positively, but when minus and when it will go, suppose what I'm trying to say, when it is, this is one of the nucleus and here one nucleus is there. Okay, so when they are coming close or going far away, means suppose this is A and this is B. Okay, now the distance between A and B is this separation distance, which is RAB. Okay, now when A and B, RAB is 0, means this is top of this, right? So then when RAB is 0, means the internuclear distance is 0, then this is the case what I have drawn here inside this box. See, so this was your 2s orbital and 2p has come over it, exactly over this, right? Then you see, then there is some positive overlap and there is some negative overlap. Means I am talking about the signs. Suppose when suppose think about this positive lobe at first, and this is your 2p orbital. Huh? This side is plus, this side is minus, and here is your 2s first node of 2s. Sorry, first lobe of 2s. Actually, how does 2s look like? 2a, if you draw something like this, then this is how your 2s looks like. I think Sad has also mentioned a lot of time. This is your y-axis, suppose amplitude, and this is your uh, distance, or you can say z-axis, internuclear distance, right? So at very close to the origin or very close to the nucleus, you can see this is that if it is 2s, if it is plus, then this lobe is minus, right? So that is what I'm saying. The first lobe is positive and the second lobe is, I am not drawn yet. Let me use another color maybe for that. So this is the another lobe of the 2s. It is not, so see, we know 1s is this, only one circle, but 2s is actually, it has a radial node, right? So inside it is plus and after the node it is minus, so there is some node is there. So I'm not drawing the node. Node is something like this. Are you getting my point, what I'm trying to say?
Yes, yes.
So maybe that was a forced yes, but seems like, so see if
No,
you,
no, no. I'm
so
getting it.
if you think about the first plus there, then the at one side this is positive overlap and this side this is negative overlap. I'm just saying in a hand waving manner. I'm not going into the integral or something like that. I'm
Yes.
just saying, see, for the first lobe, one side is plus, another side is minus. So they will cancel each other. The overlap will cancel each other, and again there is a lobe which is minus. So minus minus, this side will be positive overlap, this part, and this side will be minus plus will be negative overlap, which will again cancel each other. So overlap, sorry, overall overlap would have been 0 when RAB is 0. So that is why I am choosing the second option. When R is 0, then your overlap is 0.
Okay. You got it.
And you will see that at no point it would, the overlap would have been negative. Okay, for a bonding case. So now this is the case when RAB is 0, then at certain distance, so this is one case when RAB is 0, Then at the position, what will happen that I am again the color is, I am not changing the color at certain distance. This is minus, this is plus. So they will overlap, and something like this plus, and overall this kind of minus, and then there is a plus lobe would have been there of this. So this is an positive. So even though these are two negative signs, so those are phases, right? But the overlap is not, means what I am trying to say, there is an positive overlap. Positive overlap means there is some overlap taking place. Negative overlap means there is no overlap. That is what I am trying to say. So there is some overlap here. So suppose I change the sign of the minus and plus, then the overlap would have been, say, this would have been the bigger lobe would have been the plus. But what I'm trying to say, there is some overlap. And when you go further, means when you separate both the orbitals to the infinite, then there is no overlap, that is zero. So at no such point it is happening that anti-bonding kind of thing is happening in this case. I can't go R towards negative, right? Your R can, R or RAB can maximum go to from 0 to infinity. It can't be negative. I mean, if you can say that if I cross this distance and come this side, that is not the option we have. Okay, so we have the R. So your R can move from 0 to infinity. At that distance, it is not negative. Okay, I hope we can go to the question number 6 maybe. Choose the incorrect statement from the following options. In bonding molecular orbital, there are a lot of things. Okay, choose incorrect statement, not the correct. So most of them are going to be correct. So in bonding molecular orbital, the electron density is low in the region between the nuclei of bonded atoms. What do you think? I think this is incorrect, because in bonding molecular orbital, electron density should be higher, right, than the antibonding. What about the other statements? The energy of antibonding molecular orbital is higher than that of the atomic orbitals from which it is formed. It is true. The second one is correct. Then every electron in bonding molecular orbital contributes towards the stability of the molecule. This is also correct statement. Then antibonding takes place when the lobes of atomic orbitals have different sign. This is also true. So the first option is the incorrect statement which we had to means point out. So this is the correct answer. Can I go to the next page? Next question. Question number 7 maybe. Okay. So there is actually a mistake in the question. Previous year we have actually solved it means we have corrected the question, but this year I think there are some mistakes from the other TAs, but actually this is not, this will be a MCQ type question, this is not MSQ. And I think in the solution it is given that exchange integrals lower the energy of a MO. Actually the correct answer, only correct answer would have been, it is a purely quantum mechanical quantity. Okay, so the only correct answer. So now I am, Priyanka, are you there? Maybe. Okay, I'll continue maybe. So I'll continue to question number 8. According to the molecular orbital theory, the shape and size of a molecular orbital depends upon, obviously this is an LCAO model for molecular orbital theory. Whenever we go, this is an, so I told you that we have to take energetically similar orbital and there should be symmetrical matching between the orbitals. So obviously first statement is correct. For a MOT, the shape and size of the combining atomic orbitals matter, right? Then numbers of combining atomic orbitals also matter. This is also correct. and orientation is also going to matter. Then the symmetry will come into place. So actually all of them mentioned are correct for question number 8. Now question number 9 says if the sign of the wave function is unchanged when the orbital is reflected about its center, then the orbital is. Can you answer this question? What would be the sign says? Suppose this is your again p orbital. Suppose it is reflected from its center, so it will convert it to minus plus minus. So what do you think? This is Girard or Ungirard or both? Any clue?
I forgot. I think Girard.
Girard. Girard is the correct answer. Girard means it is having a some
Say
center of symmetry, right?
symmetry. Yes.
Yes. German word, uh, which means there is some center of symmetry like that. Okay. Now what I have shown you, this is an orbital. This is not a MO. MOT is a molecular orbital and this is a atomic orbital. So there are some difference, right? So we should not forget that. So whenever you are uh, means preparing one MO, you always have to look at the means symmetry of your um atomic orbitals. So that will also, so from there also you can understand that what is your symmetry of the MO is going to be from the idea of your atomic orbitals, constituting atomic orbitals. Okay, I'll not go there. Question number 10 says, given below is the electron charge density of molecular orbital hydrogen H2. Uh, Identify the orbital type. Can you guess which is what? See the probability it is showing that A, B are the two hydrogen atoms. So in one case the electron density is very high between A and B, and in one case there is an uh, lesser quantity of probability, means the electron density. So what do you think? Which was in bonding? Which one is anti-bonding?
First one anti-bonding. Second one bonding.
Right, correct. So this was also the, I think the one of the first question, right? In bonding, okay, we need to find the. So this question number 6. In bonding molecular orbital, electron density is low. So that is why this is incorrect, right? In case, see, in bonding molecular orbital, electron density is high in between the A and B. Okay. So after that, I thought I would have discussed something about Huckel's molecular orbitals, but for now, I'm not going to discuss that because I thought no one will join, so I have to say something. But I have a lot of question actually. I have a lot of questions. I have a lot of questions from, actually I have gathered from some coaching institute. They have actually placed it in the internet, the career endeavors. I'm just taking the, I have downloaded the PDF from there and I'm just going to solve a few questions. Okay, so this will help you in maybe in the exams, because these are very general questions, not the numerical type of questions which you are earlier solving, or you can say these could be MCQ type questions. Earlier I was solving some where variational problems or perturbation, those are big problems, but those are also important because uh, they are helpful in uh, building the concept. Anyways, so this is the first question. You have already said now, you have seen the video of um, Hakel's MO, I guess. So this
Yes.
is one of the questions, that the highest energy pi molecular orbital for the allyl system. So you need to find out of these four which wave function belongs to the highest energy pi molecular orbital. So the hint is higher the molecule, so higher the number of nodes, higher is the energy, right? This is we are considering from the particle in a box time, right? Higher the number of nodes, higher is the energy. So you don't have to think about the molecular system, you just see that how many nodes are present uh, for each cases. So what do you think in the first case? how many nodes are there? So you can see that by judging the maybe the signs or sign of the coefficient. See, the first one is positive chi1. I'm not going to the values. So positive chi1 plus positive chi2 plus positive chi3. So it will look something like, so I'm not going to the amplitudes. So this is 1 by root 2. So allyl system, it will be something like this. So these are the 3 p orbitals. Okay. Now this is positive. So this is my positive, this is negative. Then again the coefficient is positive. So I am saying this is positive, and then again this is positive. I am writing this is positive. Okay. I am not going into the uh, amplitude. If you see, then amplitude of this is higher actually, the middle one. I think in SAR's lecture you will find that very well for ethylene and for maybe 1,4-butadiene. Okay, so here what do you think? How many nodes are there? This is for the first case. How many nodes are there? If you see that there is no nodes, zero nodes, because positive, positive, positive. Node will come when your sign changes, right? So what about the second one? Second one will look like something like this. First,
One node, no, for the second one.
yes, one node, but yes, one node along the second atom, and there is no p orbital in this case. So this is actually something like non-bonding kind of situation. Okay, so this is negative. So your lobe is this side. There is only one node. What about 3? So first is positive, means by our convention, you can
Two
take
nodes.
first one as negative also, right?
Two nodes.
Two nodes, right? Which is here one, and the sign changes, so there are two nodes. So I'm just writing here 0, here 1, here 2. What about 4?
No nodes.
No, think. I'm drawing, but you think. This is the first P, which is positive. Then see, it is
Ah,
minus. So
yeah. One node.
one node, and this is again similar. But actually amplitude is different. I'm saying that it is 1 by 2, this is 1 by root 2, it would have been bigger. But okay, now we are considering the only energy, so one number of node is 1. So number of node is higher in case of 3, right? 2 nodes. By that analogy you can say this has highest energy pi orbital. You get it? So in questions, if something comes like in a lot of decimal places is coming, okay, suppose one psi is given such a way there are a lot of decimal, so you are possibly to get confused between that, but it is always easier that if you think about in terms of nodes, just check the signs and draw if you want to, or you can see from here also. See, this is plus plus, so 0 nodes. Mm, this is sign changes once, then again sign changes, so here one node, here one node, here one node, here one node, there is no node. From here also, from question itself, you don't have to draw these things. Okay, from that you can have the idea, and as it has higher number of nodes, it has higher energy. Okay, I'm going to the next question. If you have any doubt, you can always stop me. Okay, now this is the question from variational theorem. Okay, the energy functional from a trial wave function is given. That means they have already done that for what we do for a variational method. We do that psi, then your Hamiltonian, psi, and then if psi is not normalized, then we get the value of energy which is dependent on this variational parameter. So they have already found out this is alpha square minus 3 alpha by 6. So what they want to know, the variationally optimized energy. So how do we do that actually? So to understand what is the value of alpha, after this step, after measuring, after calculating the energy, we check at where this energy has zero slope with your alpha. So we take a derivative of energy with respect to your alpha, which will come here as 2 alpha minus 3, right? And by 6. By 6 will be there. So we have just taken one derivative, and that will be equals to 0. You know why we put d e by d alpha or this parameter equals to 0? Why this derivative should be 0 for alpha to be maximum? Actually, this is nothing but the slope, right? Why the slope is 0 means, suppose your this is e, okay? So suppose this is alpha, this is e. If e is monotonically increasing like this, then it is not the maximum point yet, right? At the maximum point, suppose then after again it will decrease. So at the maximum point, at this point maximum, see, the slope is 0. That is why we are taking d by d alpha 0. Now you may have the question that when there is a minima also, that d by d alpha will be 0. Yes, so this is known as that inflation point. And this, when d by your d alpha, the variational parameter is 0, you are taking at this, actually there is the change in the slope. Here this is positive slope, here negative slope. So whenever there is a change in the slope, your d by d alpha is going to be 0. Now from here you will get your alpha value, which is I guess 3 by 2. Okay, so now you have to put your value alpha here. So now is 3 by 2 whole square minus 3 into 3 by 2 by 6, which is 9 by 4 minus 9 by 2 by 6. 9 by 6, 1 by 4 minus 1 by 2, which is 1 by 4, I guess, right? Minus 1 by 4. So 1 by 4 minus 1 by 2 is actually minus 1 by 4. So I'll erase this. I hope you are getting the calculation right. If not, then please ask.
I'm doing it.
Okay, okay, good. So it will be minus 3 by 8. The second option. Actually, see, when d by d alpha equals to 0, then you can either get a maximum value or a minimum value, maximum or minimum. So, so what is the next step? You can put the value of alpha. If you are getting two values of alpha, you can put the values of alpha and see that what are the values you are getting. Suppose for one value you are getting higher and another you are getting lower, then whatever the higher value, that is your maxima, and whatever is the lowest value, that is your minimum. Or another way to do that is check the double derivative. If your double derivative comes as positive, then I guess it is minima, and if the double derivative is negative, then it is maxima, something like that. I'm not recalling exactly what it was. Yes, from here also you can see. So if you take a double derivative of e alpha by of d alpha square, which is d by d alpha of sorry 2 alpha minus 3 by 6, you are going to get a positive value, I guess. Okay, I was saying wrong thing. 1 by 3. So you are getting a positive value. So if you are getting a positive value, then it is a maxima. Okay. So if you are
I'm not getting 3 by 8. Just give me 1 minute. Huh? I'm just solving this.
sure. At which step are you in?
Did 9 by 4 minus 9 by 2 divided by 6. Then I did is cross 9 into 2, 18 minus 9 into 4, 36 divided by 8.
I didn't get you. You got the alpha value 3 by 2, right?
Yes, I got the
Now
alpha.
you are putting your value 3 by 2 a square
Yeah. Yes.
minus 3 into 3 by 2
Hmm. So
overall
9,
divided by
9
6.
by 4 minus 9 by 2. So I was trying to solve in the numerator itself. 9 into 2, 18 minus 9 into 4, 36 divided by 8.
Hmm.
So 18 minus 36 divided by 8 upon 6. I'm just doing this. I got it. Minus 3 by 8. I got it. I have just done some mistakes. Yes.
So the best way would have been to mean the inner the time solving way would have been you take the 9 out because 9 is common or
Yes,
9 by
yes,
2.
yes, yes.
So you have to do less calculation, right? Okay. Now this is one of the question comes in the CSI and NET. It used to come. I don't know if it is coming right now or not. The question is an unnormalized wave function of hydrogen atom is given by r square e to the power minus r by 3 multiplied by the spherical harmonics, the theta and phi dependent part. There is no phi dependent part for here. R dependent and theta dependent part is given. So there is no phi dependent part. So the question is the three quantum numbers n, l and m associated with this orbital are what? Do you know the process how to solve this? The trick? So actually there is a trick.
No, I don't know the trick.
Okay. So see I have said 2 times that there is no phi dependent part, right? So your phi dependent part is a dependent on m value, right? So if there is no phi dependent part, then there is the m value is 0, right? Because your phi dependent part has e to the power minus im phi, something like that, right? And some normalization constant. I am not going to the normalization constant yet because we don't require that. So if your m is 0, then see your e to the power minus im phi, that exponential e to the power 0, it is becoming, then it is 1. So that's why there is no phi dependent part. So actually it would be either 1 or 3, means your m value is going to be 0. So you have means so your these two options are cut. You know these are not the correct answer, 2 and 4. Okay. Now next, how to get the value of n. Okay, the value of n can be, so actually if you remember the, don't have to remember the Laguerre polynomial, actually the solution of that. So actually in radial part you used to get something z r by n a. Okay, where z is your atomic number. For hydrogen obviously it is 1, right? Then r is your, obviously radius r. N is, you know, NLM, your that primary or fast quantum number, right? This is now N, and A is the diameter, right? A is what? Yes, A is the diameter, right? So this is, so it is, so your psi, or I should say psi, varies as, so this is one of the component, right? So here if you see, it is e to the power minus r by 3. Okay, so they have taken, so whatever has happened with a, we don't want to know. Actually they should have write here r3a. I think whatever exam you are going to see, I think they have made some mistake. 3a should have been there. From there you can, and if it says it is hydrogen, then your z is 1 already. So it is something like e to the power minus r by na, right? You're getting my point. So from there you can get the value of n. So actually here your value of n is actually 3. So m is 0 and n is 3. So your this is going to be the correct answer. And the whatever is left, n, right, values of 2, that can be get from this r square. R, how can you get that? That your n you understand you are getting from here. M you are getting from the phi dependent part, and L you can get is the lowest order of the polynomial. You, you understand what I'm trying to say? So this is an polynomial of R. So the lowest order is R square. So that is 2. The order is 2. So that is why your L is 2. Suppose this R was, suppose this is R to the power 0. Okay, there is no R, which is in case of 1s, right? There is only e to the power minus r by something. If you don't have to remember, but I was solving some problem, that's why I remember that it did not had any term of r, means in polynomial of r the lowest degree was 0. Okay, so that is why I am saying here your L is 2 for this particular case. So did you get the trick? So you will
Yes.
get the value of n from the exponential term, you will get the value of m from the phi dependent part. If there is no phi, then it is 1, and if it is 1, then your m have to be 0. That is why your em phi, e to the power im phi, or plus minus im phi, as m is 0, that's why that phi dependent part is 1. So this is one of the way to quickly get the answer. Means you don't have to remember anything about the wave function, just look at the wave function and you can say which orbital it is. So we'll later also verify if we are getting some of these orbitals. Okay, so let me go to the next question. Okay, so I need to remove these writings from here maybe. Okay, let me keep it here maybe for the time being. Okay. So question number 4 says a satisfactory spin wave function for an excited state helium. So actually we are here discussing about, so as this is the last live session, I am trying to give you the possible questions that may come from all over the quantum for the last 12 lectures. Okay, that's why we are jumping from hydrogen to this helium problem and all, one dimensional box. So don't worry about it, just I'm giving you questions you can later also solve before the exam. So the question says that a satisfactory spin wave function for an excited state helium. So helium in ground state is 1s2, right? So in, suppose the excited state is 1s1, 2s1, right? And obviously electrons are indistinguishable, so you can't say which one is. So for this case it could have been alpha 1, beta 1, the spin part I am saying, or it, sorry, alpha 1, alpha 2, or beta 1, beta 2, right? And this case, it could have been, so I am not making sense. I'm sorry, whatever I have just said, that is wrong. So they are in a paired state, right? So it should have been either the first electron should have alpha and the second electron should have been beta, right? Here for this case, particular case, actually whatever I was saying, let me write in terms of spatial wave function. I'll erase this all. Oh my god, this is not going right now. I'll delete it. Okay, this question. So this is in excited state. This is helium in its excited state is 1s1, 2s1. Okay, so how does the spatial wave functions look like? That so first electron 1s could be in 1s and second 2a, the second electron could be in 2s, but as they are indistinguishable we can't really say. We have to take a linear combination, right? 1s, the second electron is 1s and first electron is in 2s. Are you getting my point, what I'm trying to say here? So this is
Yeah.
the spatial part for a
Yeah.
helium excited state. As electron are indistinguishable, the first electron could be in 1s or could be in 2s. Yes, we can't really distinguish. Now accordingly to this, your spin wave function will vary. So I'm not going to that. I should go. That will be a quick recapitulation maybe. So suppose this is the plus combination. Okay. So if psi, I am writing psi plus spatial. This is the plus combination. If plus combination you see is symmetric and psi minus spatial is antisymmetric, and antisymmetric with respect to the change in the electron number, right? If the electrons changes, then the positive, that is why the plus combination is symmetric and minus is antisymmetric. And whatever we have learned from the for the fermions, that they follow a antisymmetry principle, right? So this is what we are saying, that what is the symmetry of the spatial part, that psi plus condition is symmetric and psi minus is antisymmetric. Now for fermions and from the postulate 6 we know that overall symmetry is going to be negative, right? So sorry, overall wave function is going to be antisymmetric. So for this case your psi spin have to be antisymmetric, right? So that your overall psi total become antisymmetric, and for this particularly your psi spin have to be symmetric so that the total spin remain antisymmetric. So as you can see, so for the first part, so for the positive one, you have only one spin part. Okay, so size plus spatial. I am directly writing the spin combination because there is only one option. Your first electron either could have alpha and second have beta, and your second electron could have alpha spin and first have beta spin. This is the only antisymmetric spin combination that is possible, right? Priyanka, are you here?
Yes, I'm here.
Okay. So one of the combination where your psi plus you are taking a symmetric spatial, then you are only having one uh, combination, possible combination of antisymmetric spin. But when you are taking psi spatial to be negative, then there are actually three combination, symmetric combination of spin, which is alpha, both are alpha. See here I am denoting the electrons 1 and 2. So this is 1s1, 2s1, but what I am trying to say, one electron is 1 and another one is in 2s. So alpha 1 and both could be beta, that is another combination, and another is obviously the plus combination, right? Whatever I have written in minus, that is in plus. So that's why as you are getting three degenerate state from here, that is why it is known as triplet. Okay, and this is known as singlet. As there is only one spin state, and here there are three degenerate means in energetically degenerate spin state. Obviously if you give magnetic field or electric field, they are going to have different energy, but I am saying in gaseous phase or in normal time they are degenerate. That is why they are known as triplet state. It is not actually, it is wrongly, I should say wrongly used that 2s plus 1, if it is 3, then we say this is triplet. Okay, and when 2s plus 1 is 1, then we say singlet. Actually this is not correct. If you think about this triplet condition here, see, this is sorry, singlet condition itself, see there is alpha and beta both having two different spin. So conventionally it would have been a what it should have been, sorry, this is correct because then your spin would have been 2s plus 1 would have been 1. But see, in this case alpha 1 alpha 2 beta 1 beta 2, in this case you see, your if both having this value, sorry, for this part I'm sorry, uh, for this third case alpha beta both having different spin. So by that analogy means I am saying 2s plus 1 equals to 3. If it is triplet, then see here the total spin is actually going to be 0 because alpha and beta are there. Even then also this is called as triplet. Actually the triplet and singlet coming from these wave functions, not from this nomenclature 2s plus 1 is 3 and 2s plus 1 is singlet. Okay, I hope I could help you in this uh, concept. So this is what we use from our childhood, or you can say from 12th. This is actually a wrong notion that has been taught, that 2s plus, if it is 2s plus 1 is 3, then it is triplet, and if it is 2s plus 1 is 1, then it is singlet. Okay, actually why it is called triplet and singlet, because they have three spin state and here it is one spin state. And you can say that in organic reaction or in that cases where this has been mentioned that 2s plus 1 equals 3 triplet or singlet state, how the calculation actually matched, that is because you can see that for the triplet scenario, two-third of the case, almost 60% of the case is actually matching, that 2s plus 1 is 3. Only the 30%, 33% is your alpha and beta. That is how if you think about last Atelier principle, that triplet to single. I'm sorry that I'm going somewhere else, but I hope you understand this idea, right? Why it is called triplet and why this is singlet.
Yes, I
Okay.
got it.
So okay. Now if you see that, what would be the answer here? A satisfactory spin wave function for an excited state helium atom. Obviously it cannot be alpha 1 beta 2, right?
Yes.
Because you can't distinguish.
Hmm.
So this is not alpha 2 beta 1. This will not be an
The
answer.
first one.
First one, and second one is also not. Let us go to the question number 3. So question number 3 says, for a particle of mass in an mass m in a one dimensional box of length 2n, the energy corresponding to the level to n equals to 8, what would have been? N equals to 8. So the energy would have been 8 square h. So let me first write the formula: n square h square by 8 m l square, right? If the length is l, let me write a square, then it will be better. Now here I am writing 8 square h square by 8 m 2l square. So 1 8 is gone. Then here 8 h square 4 m l square. So 4 8 2, so 2 8 square by m l square, which is your actually option D. So I did not spend much time here because this is easy, right? I hope you
Yes,
got
yes,
the point.
yes, I got it.
Okay. So should I let me discuss something about this week 11 assignment. I am not going to give you the answers, but I am going to give you the hint how you can solve this. Okay. So the first question was that ionization energy of an atom A is given as 13 electron volt. Another atom B. Acha, so let me draw this case. So one is A and B has two kind of ionization energy. So suppose this is the ionization barrier. Okay, and let me draw something which is very important, that your energy scale. Whenever you are drawing some MO, you should mention this energy scale. Actually, I lost some of my graduation marks because of this, so I remember it very well. That I should not miss this. But yeah, so they are saying that ionization energy for A is 13 electron volt. Okay, so this energy is 13 electron volt. B has two kind of energies. One is 15 electron volt, another is 20. So if it is ionization is 15 electron volt, then it should be has two orbitals which stays below A. Okay, so this is 15 electron volt and this is 20 electron volt. Okay, so for the molecule AB, so now when they form the molecule AB, then they will form some, these are atomic orbitals. Now they will form some molecular orbitals here and there. Okay, are you getting my point? So they will form something like here one, and it could be something like this, right? So so from XPS, so this technique is called XPS, right? Photoelectron spectra, photoelectron X-ray photoelectronic spectra. Okay, so for the molecule AB, they are getting three ionization energies. That is because they are having three MOs. Okay, three molecular orbitals. Let me draw in some different pen color. So this is one of the MO they are saying. This is one of the MO and this is one of the MO. Why I am constructed like this? Because they are saying one of the MOs having energy 12.8. The scale is not correct. See, this is 13, this is 12.8. This is, they are actually close. This is little higher than this A. Then another is having 15 electron. Acha, I should draw properly. Okay, I got what they have done. So did you get the idea how what they have done? So this is actually the 12.8. Okay, so there is some increase from here, and they are saying this is actually a non-bonding MO, right? Because it also have 15 electron volt. Okay, and another the last MO has 20.2 electron volt. So this is actually a bonding MO. Okay, this is a non-bonding MO and this is a anti-bonding MO of this. Suppose this is A1 and this was your B. So B has B1 and B2 orbitals, atomic orbitals. So A1 and B2 actually form a bonding and anti-bonding, but B1 actually formed one non-bonding MO. Why this is so? The possible reason is that, however, the energy is close, maybe the symmetry is not there between A1 and B1. That's why B1 is acting as a non-bonding. The symmetry of A1 and B2 may be similar. That is why they are forming this kind of bond. MO, right? One bonding MO, another anti-bonding MO. So from here, so they are also saying there are 4 valence shell electron in AB. So you need to put your electrons here, right? So there are 4 electrons, 1 electron here, 2 electron here, and second electron will go to your actually non-bonding, not in the anti-bonding. Now based on this, you have to give this answer. Okay, don't give the answer right now. I have just shown you the image. You can think this of as a hint. Maybe you could have done it yourself also, but based on this, you will be able to solve these 3 questions, right? What do you think? The first question is the correct statement among these are all. The bond is, if there is a bond, so bond means the bonding MO.
Yes.
Don't give me the answer, huh? So
Okay.
okay, so you can see where the electron is. So and what is the energy of bonding MO, which orbital it is close to.
Yes.
Then you can get the idea that for which your bond is polarized to, and whatever electron there is in the non-bonding, they are known as lone pairs. So based on that, you can also say like that, huh? By the energy, whatever is there,
B1 is non-bonding, no, here.
B1 is non-bonding.
B1 is non-bonding. Okay.
So you can also idea that where is your lone pair. Okay. Now you know how to calculate the bond order. That
Yes.
is your bonding electron minus anti-bonding. So there is no role of non-bonding. You will get that. Then the third question is, if AB forms a coordination complex with metal complex, then what will be what? So what do you think that acha, then we'll give the answer actually. Let me see the questions actually, the options more carefully. A is sigma donor. Okay, I got the idea what could be what, right? You got the idea that which could be sigma donor and which could be pi acceptor, right? So you
Yes.
can, okay, okay, we are not going into that.
Okay.
You can answer that. Okay. Now, should we discuss this question in delocalized MOT? I hope you will be able to solve that. Delocalized MOT. So in MOT actually you are going to get the delocalization, right? In your VBT, delocalization was not there. We have talked about VBT, hybridization. Hybridization, we are saying that the hybrid orbitals are directional. So that is actually we are localizing the electron, not delocalizing. Okay. So I think the example of methane was there. The delocalized theory was also taught using MOT, and from there we have understood that MOT is actually far more superior that of the VBT, as the delocalization concept is coming. For because from experimental spectra you have received 1:3 in intensity ratio, right? But if you would have chosen a delocalized non localized MO picture, means you have first prepare the hybrid orbitals from your atomic orbitals, then you are going for the MO picture. That was actually not experimentally correct. I hope you understand which lecture I am talking about. I guess 65, lecture number
Yes.
65.
Yeah. Yeah. Where CH4, this is
Yes, for methane.
discussed. Yeah.
Yes. Now the question number 5, photoelectronic spectrum of two bands B1 and B2 with lower and higher ionization energy. The A ratio of areas under B1 and B2. Is it still? Acha, the photo. Acha, it is for methane. We have discussed already, right? So in the you will be able to do this. Now the question number 6. This is from Huckel's molecular orbital theory. Energy of bonding pi MO molecular orbital of ethylene E plus. I guess it will be the first. I don't remember exactly. I still gave you the answer. No, not to worry. Now the seventh question. You will be able to do this. What
Yes.
are the Hakel approximation we have taught taken?
Yes.
That is
Yes.
okay.
Yes.
Now I am going to some questions from actually these are taken from Career Endeavor. Let me acknowledge them. I'll if I am not able to solve all the question. Acha, we have time till 8. We have still 40 minutes. I think we'll be able to solve a lot of questions
So,
from.
NPTEL exam point of view, these kind of questions will be asked, like what we are
Yes.
solving now, or what were given in the assignments.
So whatever kind of questions I'm going to solve now, these are also the similar type of questions what you can get in the assignments. Suppose this is another set of question.
Okay. Okay.
Okay.
And what are the like total number of marks and timing for the exam?
I have to check actually. I think the questions is yet not set, I guess, because it would have been come to me for checking maybe. That
Okay.
as a TA.
Yeah. Or
Uh,
if you could upload like a sample question paper of the previous exam or something like that, so we have an idea about uh, the exam paper is of how many marks and how much time is allotted.
and most of the time, what happens that the question, some of the question may get repeated, one or two questions, or maybe 5 or 6 questions. Okay, that's
Okay.
why I guess
Okay.
they don't share the previous year question.
Okay. Okay. No
Okay.
problem. But just if you get an idea about the
Actually, it
timing
will
and
be similar to the assignment, or maybe the kind of questions, right? What we are trying to going to solve, most of them. Okay, like
okay.
the net questions. It is
Okay.
not very high, but you will need some concept and maybe some mathematical thing. Okay,
Okay.
not very high sum. Okay, let us solve this question that for a eigenfunction is given 1 by pi sine 3.63x and the operator is given. What is your eigenvalue? Can you quickly tell me what is going to come? Minus h cut square 8 pi 8 pi square m d square dx square 1 by pi sine 3.63x. So I know that see, when you take double derivative of sine, you are going to get back sine, right? Because sine 1 will go to cos, then again from cos it will become sine. Just you are going to get this thing extra, so that I will write at the end. 8 pi square m, this would be there, right? Then 1 by pi is constant, that will come out before the derivative. Now the double derivative will lead to minus 3.63 whole square, because it will come twice, right? And your sine. If you have any doubt, you can ask. So it is going to be minus 3.63 whole square. What's a minus it will become plus. Okay, minus and minus will become plus h cut square. Acha, they are saying h square, not h cut square. So I have just changed my h cut to h, huh? By 8 pi square m, and remaining is sine 3.63x, which is again your psi, right? So this is your eigen function and this is your eigenvalue. So The first option is I guess 3.63 square h square 8 pi square m, right? So B is going to be the correct answer. Did you get the same answer? The idea how to solve this is a very fairly easy question, right? Just you quickly you need to check that you don't have to calculate the value of sine 3.63, right? You know that if you take a double derivative you are going to get it back. If it was only once, then it would not have been an eigenvalue equation itself, because it would have been generated a cos function. And why did I take minus here? Because it will convert sine to cos once, but the derivation of cos will give you minus sine x. That is why I have taken a minus sign.
Minus. Yes.
Okay, let us go to the next question. So the next question says the particle in a 1D box with infinite potential wall at x is equal to 0 and obviously x is equal to L is in the n equals to 3 state. Now the probability for finding the electron in the range of 0 to L by 4. So I will delete this part so that we can discuss these questions. Some question here maybe. So actually if you remember the wave function, how it will look like for n equals to 3. Achha, I will draw all of them, so it will be a recapitulation, right? N equals to 2 and the minimum would have been n equals to 1 because for particle in a box there is nothing n equals to 0, right? So n equals to 0 looks like this, have no nodes. N equals to 2 actually have a node here at L by 2. Okay, this is 0, this is L by 2, this is L. And what about n equals to 3? It will go like this and have a minima at L by 2, and again come back and like this. There are two nodes in n equals to 3, right? So the question says, see, this is from here also you are going to get an idea that this is L by 4 and this is your, actually this is your 3L by 4. It is not properly scaled, but I hope you are going to get that idea. So they are asking about this part, that what is the probability, what is the probability of getting your, finding your electron in these locations 0 to L by 4, between these. Okay, so the options are greater than 1 by 3, exactly 1 by 6, exactly 1 by 3, none of the above is correct. Actually from here actually you can't really have the idea, you have to solve the integration for that. For n equals to 3 it is obviously root over 2 by L sine 3 pi x by L, right? And obviously for getting the probability you need to integrate it from 0 to L, square of this and square of these two, and integrate over all over this space, or you can say along dx. It will be 0 to L 2 by L sine square 3 pi x by L dx. Okay, which will lead to your 1 by L 0 to L 2 sine square 3 pi x by L, which is 1 minus cos 6 pi x by L dx. So now this will be easy to integrate, and I hope you are going to find something 1 by 4 minus some positive term, something. So that is why it is not exactly 1 by 6. This is not greater than 1 by 3, and it is not also exactly 1 by 3. Actually the correct answer would have been none of these ever. Okay, you can solve it later also. Actually, we have a lot of questions, so let us look at the question and try to solve them so that uh, we can have a good set of question to discuss. So I'm going to next question. Huh? So the next question says that which one of the acha, I have a low battery. Let me switch on my laptop. Yes. Now the question says which one of the following statement is true about the particle in 1D box with infinite wall. Okay. So psi 3 is the third. So when your particle is in or the electron is in n equals to 3. Okay. So they are saying that psi 3 square is 0 because wave functions are orthogonal. Is it true, Priyanka? Psi 3 square dx integral is 0. Is it true?
I don't think so.
Yes. It should have been 1, right? Because it is a normalization constant condition. It should have been equals to 1.
Yes.
What about the second? Psi 1, psi 3 dx is equal to 0 because this function was symmetric.
Yes, no? Psi 1.
No, no. Actually, first part is correct, but the reasoning is
Psi,
wrong.
Psi 3. Okay, Psi 1 is which belongs to n is equal to 1, no?
Yes.
And
It
Psi
is
3.
symmetric. Both are symmetric. But that is not the. So that is actually a correct, right? Um, that is actually not why it is 0. I mean, they are symmetric, obviously, but that is not the reason why it is 0.
Hmm.
It is 0 because they are orthogonal. That is means the fourth point.
Hmm. Correct.
So actually, when Sir has shown for the transition moment integral, that point it was important because then you had a dipole moment, term inside the integral, which was uh, antisymmetric. Okay, so your integral was being antisymmetric because symmetric into antisymmetric into symmetric, and an antisymmetric integral will lead to integration value of 0. That is why that was about the transition moment integral, but this is only about the normalization and orthogonality. So the fourth option is correct, the second option is not correct, and third option is also not correct because same reasoning as A, because those are different, so conditions are given. Okay, now question number 4, which of the following is true? So there are 4 options are there and each have 3 sets. Let me not solve this right now. Take a screenshot maybe, or you can see it from the um, um, video. I'll give you the right answer. Try to see why it is correct. Or should I give you the correct answer, or you
No,
want?
I'll do it. I'll do it.
Okay,
I'll
okay,
do it.
okay, okay. Good, good. So let us not discuss it here because we can't. Acha, let us discuss maybe. What do you think? Lx and x, are they going to be commutator is going to be 0? What is Lx? Angular momentum along L, right? Sorry, angular momentum along X.
X
So
axis.
minus I H cut. Easier way to remember was Lx, Ly, Lz, X, Y, Z, d by dx, d by dy, d by dz. So minus H cut, Lx is Y, d by dz. Actually, I should have written this in terms of px, py, pz. Then it would have been make sense, right? IH cut, IH cut, IH cut, which is nothing but PX, PY, PZ. Huh? I will rewrite. So this is what I'm writing is I'm taking the minus I term common and I'm writing the rest of the thing. It is Z d by dy.
I think the C is correct. L square Lx is equal to 0.
Mhm. Does y and py is 0? What is
Wait.
py? Py is uh, minus ih cut d by
So
dy.
momentum, no? Of
Yes. You,
H.
you you tell me if is it correct? X px. This is a very common thing we discuss. Your position and momentum are they commute? They do they commute? If they commute, then they could have been uh, measured simultaneously at the same
Yes.
time, but
Yes.
that is
We
not
cannot.
implied
No.
Heisenberg
No.
uncertainty principle.
Yes.
What is
So
the
it's
value? I think minus IH cut or IH cut, the value of the commutator.
minus H bar I.
Minus H bar I, which
H
is
bar divided
IH
by
cut, which is IH.
IH. Yeah, correct.
Correct. So in this case also similarly for y dimension, you think if y and py will they commute? They don't, right?
No, no,
Here
no.
also you are going to same IH cut. So that is wrong.
Hmm.
What about B? Y and px commutator is 0. That is true. What about Lx and y? Hmm? Lx and y. You need to check, I guess.
Yeah.
Put the value of y there, maybe.
Lx and Y, no?
Yeah. You try solving this. It would be
Yes.
interesting.
Okay.
It is already known that C is not going to be correct, right?
Yeah, C is not correct. The top one is correct. Lx square into
Yes,
Lx is equal
middle
to.
one and the top one is correct.
Yeah.
And also this is not correct because of the last one, right?
Hmm.
Now you have to think between B and D.
Yes.
Okay. Do that and we'll get something.
Can you give the correct answer so I can solve now because I've
The correct answer is D.
B D.
D.
Okay, okay,
And that's why I didn't touch that
okay,
during the discussion.
okay.
Okay. Okay. You try to solve this, huh? Right?
Yes,
Okay.
yes.
Next, another question. They consider the quantum mechanical problem that the eigenfunction is spherically harmonic. That y lm, right? And L is 1 and ml is 0, so that your wave function is given like this: y10 theta and phi dependent is n cos theta. So you need to find the normalization constant. So what you have to do, you need to go for normalization. So this is a double integral, right? Spherical harmonic, theta and phi dependent part. So first you need to take the square of this in cos square theta. Now what is d tau here? D tau is volume element. Volume element would have been sine theta d theta and what else? D phi, right? No art dependent part, right? So here you write sine theta d theta and d phi. What are the limits for theta and phi? Both will start from 0. What is the limit for theta? You remember for polar coordinates? 0 to pi. And for d phi it was 2 pi. It was something like this. Theta yeah. This is r, this is y, this is x, this is z, and this was your r vector. And this, whatever angle it makes with z, it was theta. It can actually grow from 0 to pi, and whatever the projection of r in xy, that is I guess r sine r cos theta, r sine theta. Okay. that makes an angle phi with x-axis, right? So that can have a limit from 0 to 2 pi. Okay, so that is one important recapitulation was required, and normalization constant, so it should be 1, and then you try to find out what is the value of n. I will give you a hint that to do it easier, put x is equal to cos theta. So your cos square theta would have been x square, and dx is sine minus sine theta d theta, and also change the limits. Theta x, your theta goes from 0 to pi. So at x theta equals to 0, your x would have been 1, and pi it is minus 1. So I will give you the modified integral, which is 1 to minus 1 minus n square x square dx, and obviously 0 to 2 pi integral of d phi is going to give you 2 pi is equals to 1. Okay, from there you can get the value of n. Try to find what is the value is coming. I think you are solving it. Solve it and then tell me.
Just give me a moment. I'm trying to
Yeah,
solve.
sure.
Can you solve it with me?
Yes. So
Yeah.
you got at least up to this part what I have written here.
Yes.
Okay. So the integral of x square is x cube by 3.
Yes.
So let me write minus n square x cube by 3 as a limit from minus 1 to 1 into 2 pi, which is equals to 1. Now let me go to this side maybe. Then we have minus n square. Then for minus 1 cube would have been minus 1 by 3, right? And then minus 1 by 3 into 2 pi is equals to 1. Let us take all the minus common, and it would have been minus minus, all would have been plus. So n square into 2 by 3 into 2 pi, which is 1, and your n square is 3 by 4 pi, and n is root over 3 by 4 pi, the D option.
This is quite a lengthy problem.
But this will come, this may come, because actually they can't give subjective questions, because the questions will be automatically checked by the internet, right?
Yeah, correct.
So they want to solve you and then give them the answer. But was it conceptually hard? It was not conceptually hard, right? It was just little lengthy, not much lengthy. Is it lengthy?
No, at that moment it should strike you not to solve it this way because
Uh,
exam tension. I don't know. I will be able to remember the concept also.
no, you will be able to, because this is just a normalization thing.
Okay.
Much harder question may be there.
Yes, yes. True.
This is maybe the easier one. Okay, let's. I hope you got the problem. Maybe
Yes.
you can solve it. Okay, let's go to question number 8. Consider the following statement. All eigenvalues are real. This is statement number 1. The statement number 2 says eigenfunctions of Hamiltonian operator are orthogonal to each other. Okay. Third, let us go one by one. What do you think about the first statement? Are all eigenvalues real? Quantum mechanical. Let us
True.
true, right? Because all quantum mechanical operators are going to be Hermitian, right?
Yes.
And then they are going to have eigenvalue as real. Then eigenfunction of Hamiltonian operator are orthogonal to each other. What do you think about this statement? Hamiltonian operator is also a Hermitian operator, and you know all the eigenfunctions of a Hermitian operator form a complete set. Complete set means they are orthogonal to each other.
Yes.
So orthogonal and itself they are normalized themselves. Then this is also true. What about third statement? Two Hermitian operator A and B commute, and A and B are Hermitian separately. A and B are Hermitian separately.
Then
So
AB is
AB is
also.
also an Hermitian. Let's see what they are trying to say. Let me write it down. A Hermitian, then A dagger is A. B Hermitian, then B dagger is B. Now they commute. Means AB is 0. That is AB minus BA
BA.
means they are equal. So if AB to be Hermitian, do you know this dagger property that AB dagger is B dagger?
A dagger.
They interchange the position, right?
Yes.
So it is B dagger is B, A dagger is A. So this is BA. And from this commutator relationship, they have already established the AB equals to BA. So BA is nothing but AB. So AB dagger is AB.
AP.
So AB is also Hermitian. So this is also true. What about the fourth statement? The eigenvalue of anti-Hermitian are either purely imaginary or equal to 0. Anti-Hermitian, let us think of something that is anti-imaginary. So suppose your psi is Ix. Okay. So your maybe not psi. Let us take our operator, right? Let us take our operator A operator. Let me rewrite. Suppose we have an operator A, which is Ix. Then it is anti-Hermitian because A dagger is going to give you minus Ix, right? Because it is I dagger, X dagger. I dagger is minus I, X is X, right? Because I have jumped a few steps, let me not then. I is constant, so I can take it outside, but it should have been some dagger. So I dagger is actually minus I, and X dagger is going to be X because X is just a direction. So is it X dagger is actually, yeah, it is Hermitian. Sorry, X is Hermitian. So because position is a real, so you are always going to get a real value of position, right? So there is no imaginary value. That is why I am saying that I am coming from the back door, that as it is a real value position, that is why it is an Hermitian operator, right? So A dagger is going to be minus Ix, which is actually your minus A. So A is anti-Hermitian. So eigenvalue of anti-Hermitian are either purely imaginary or equal to 0. So suppose A is operating on X. Now X is can be your wave function, right? So it would be I should take something else. Maybe maybe sine theta. Why not? Right. So you are going to get minus I x sine theta. Sine theta you are going to get back. Actually, this is not a good example. What should I do? Acha. Let me delete all the thing. Okay. Sorry. I'll choose another operator. Anti-Hermitian operator. Means I am just choosing the anti-Hermitian operator so that I can get the idea. Actually, d by dx is actually an anti-Hermitian operator, right? Because delta is going to give you minus d by dx. What if you operate on x? You are going to get 1. So the eigenvalue of anti-Hermitian are either purely imaginary or equals to 0. So this is not true, right? So this is not true. So I guess the which of these are true, maybe these first 3, 1, 2, 3. The eigenvalue of anti-Hermitian. Actually in the answer they have given 4. And so all of them are 4, but as we are getting A is an anti-Hermitian operator, right? And when it is operating on something, we are getting a positive value, either purely imaginary or equals to 0, but we are getting value. Oh, acha. See. Actually, they are it is correct. See, so we are getting back 1. Okay, we are not getting back our x. X is the eigenfunction. If it is an I means eigenvalue equation, I should have got back x, but I'm just getting 1. So this is not at all eigenvalue equation, right? So that means that yes, I should not say the eigenvalue is 0, but it won't be a eigenvalue equation, right? For this particular case. So actually 4 is also correct. So as they have, so in their answer sheet also they have mentioned 1, 2, 3, 4. All of them are true. Okay, if this kind of question comes, then you can select this. What I am trying to say, when I am operating A on X, I am getting only 1. I am not getting back my X.
Correct.
So that is not an eigenvalue equation itself. Okay. So what is the next question? Oh my god. Next question is top of this. I have to delete this. How much time is left? 10 minutes. Okay. Let us try to see how many questions we can solve. Please try to solve this one yourself. Consider a free particle of mass m moving on one dimension. So h you know, Hamiltonian minus h cut square by 2m d square by dx square, right? And as they are saying free particle, so there is no potential. So this is your Hamiltonian, and x is x. So you take h and x, okay, and operate it on a psi. Okay, this is actually the correct way to do this. Sometimes what we do, that we don't take this psi and we write h x and x psi. It is good option when we are operating with the operators, but see, when someone wants to know the eigenvalue or the form, then one should always write psi. I'll let you know why I'm writing this. So hx is actually hx minus xh, right? Operating on psi. Psi is, I'm taking an arbitrary wave function. Don't worry about this. So minus h cut square by 2m d2 by dx square of actually x and psi. Okay, and then x, and it is minus minus, it will become plus h cut square by 2m d2 dx square psi. Now you see this double derivative will work both on x and psi. So we can go step by step. Minus h cut square by 2m, d by dx will remain. Let us derivative one time. What we will get? We will get first it will derivative with x, that 1 into psi, that is psi, and plus we will get x that is it is, and we will get d psi by dx, and this h cut square by 2m d2 by dx square psi. Now we can break this h cut square by 2m d by dx d psi by dx, and this part will get what? For this part we'll get, okay, good. So for this part we are going to get minus h cut square by 2m, again d by dx x on x d psi by dx. So first we will work on d psi by dx, okay. Sorry, first we will derivative with x, so d psi by dx will remain as it is, minus h cut square by 2m d psi by dx. Actually I have made a mistake. So you are getting the idea, no? What I am trying to do, I am just first I am going to derive and
Yes.
going to get the derivation of x, that will remain x, so d psi by dx will remain at is, and another would have been minus h cut square by 2m d by dx. Now did I do the right thing? No. First I have taken for this. Somewhere I have done a mistake. Here x is outside, okay. Then I could write like this, because x is now constant. I am derivating, taking the derivative of d psi by dx. Then this is the case, and then again here d psi by dx will remain at is, because this time I have went with d psi by dx as constant, and dx by dx will give me 1, and here x h cut square by 2m d2 psi by dx square, okay. Here we are getting these two term will cut. I will change my color, maybe this is 1 and this will go, right? X h cut square by 2m d2 psi by dx square. So we are left with I'll write it here, maybe minus 2 h cut square by 2m d psi by dx. Both are having minus sign. H cut square by 2m d psi by dx, which is 2 again cut. So minus h cut square by m d psi by dx. Okay, what it, so I have to write in term of p, or maybe px, you can say, that is minus I h cut d by dx, right? So I'll take 1h d by dx. Let me write psi here. I have taken 1h. I need to take minus I also. So if I take minus I here, so I have to also divide the whole thing, right? Minus h cut square by m. I also have to take minus I h cut here. Are getting my point what I'm trying to do here? Then minus minus gone, h cut gone, then I will get only one h cut, I m, right, h cut I m, and this is p x operating on psi, right? So what did we get? H cut is nothing but h by 2 pi px by m, I here, so minus I. What is the correct answer given? 9a. We are somewhere, so okay, yeah, we are getting that only, right? So this is what? If I is here, I told you, no, this is, we can write it is as minus I at numerator. H cut I am writing as h by 2 pi, and here it is px by m psi. So actually first one is the right answer. I h by 2 pi px by m, and psi is here because we have taken this arbitrary, so the psi is an eigenfunction and this is the eigenvalue. Got it?
Where is 2 pi coming from?
H
Which?
cut is there, h cut
Okay,
I am
okay, okay,
writing as
okay.
h by 2 pi.
Okay, yes, yes.
Okay. Let us see what is the next question. Next question is easy. That a electron of mass m is confined to a one-dimensional box of length 2b. It make a radiative transition from third excited state to ground excited state. The frequency of transition. So that is going to be your, so there is a trick. What is the third excited state here? What is the value of n?
3 square.
No. Third excited state is n equals to 4.
Okay, yes, n equal to 4. Sorry.
That is the
Yeah,
trick.
yes. Yeah.
Next it is h nu is, you can take is 4 square h square by 8m 2b square here because 2b is the length, minus 1 square h square by 8m 2b square. I think you are going to get something as 15h by 32, oh maybe 11a, yeah, that is what you are going to get. Okay, that was the trick. And it may come again. I think the next question is something like that. The second excited state, wave function of a particle between minus L by 2 to plus L by 2. Actually, this is a question we have solved. I have solved in between. I don't remember which week's lecture, which week's discussion session, I don't remember. But we have solved the particle in a box wave function when the limit is not from 0 to L but minus L by 2 to plus L by 2. So there we have seen that the energy value doesn't really change. Okay, the wave function actually changes a little bit. How it changes, that I'm not deriving the whole thing, but when you are going to see that when your n is going to odd, then you are going to get a cos function, psi as a cos function, and when n is even, your psi is going to be a sine function. When n is even, it is similar, root 2 by L sine n pi x by L, and when psi n is odd, you are going to see it is going to be root 2 by L cos n pi x by L. Okay, so here second excited state, that means n equals to 3, so that is odd, so you are going to get a cos function. Okay, now here it is minus L by 2 to plus L by 2, again the total length is L, remaining as L, same as 0 to L, right? So it would be root over 2 by L cos 3 pi x by L. So 12A is the correct answer. Okay. So try to see if you find this thing anywhere in our discussion session from the YouTube video, maybe from particle in a 1D box where I was discussing some Macquarie and Simon's book. I got this problem. Okay, you try to see this. Okay.
Yeah, okay.
Now the next question. Please try to get this commutator yourself. The first one, I guess, is I will give you the answer. Try to solve it. The third is the right answer because I'm got it from this one. Lx Ly is what? I h cut Lz, right? Lz is also there. Then minus I is given, minus 1 by I, which is I, and h by 2 pi. So this is nothing but I h cut Lz. Okay. Try to solve it yourself, maybe 13. Then this is another question. Okay. So for this question, you can see.
Can you go back? I'll just take a screenshot of that question. I didn't take. Yeah, just 1 minute. Yes, yes, I've taken.
Now question number 15. 1D box wave function is given a sine 2 pi x by a. Okay. You just need to get the value of a of box length. So you know what is a, right? From you already know that it is 2 by L. A is going to be 2 by L, right?
Yes.
Because for a, you know, it is sine n pi x by a, right?
Mm.
You can get it from the, you can do a hard way, means you can do the normalization thing and get root over 2 by L, but this is, you have to be smart enough, right? You know that what is going to be the value of A. Now L is given 100 nanometer, 2 by L, so it is 1 root over 1 by 1 by 50, because 2 by 100 is a, and nanometer to the power minus half. Should also remember the unit. It is going to be the first one. Try to get the answer. What about question number 16? I know I am doing a little fast. See, Lx square plus Ly square is nothing but L square minus Lz square, right? Total angular momentum, angular momentum square of total angular momentum is the square of each of the components. So I'm just taking Lx square is equal to Lx square plus Ly square is equal to L square minus Lz square. And you know already, when L square minus Lz square operate on that spherical harmonic, right? You are going to get, for L square you are going to get L into L plus 1 into h cut and get back your spherical harmonic, and Lz square you are going to get m h cut and your spherical harmonic. So this is nothing but, sorry, h cut is square. Okay. And also m square a square. Lz is mh. So you're getting it, right? What I'm trying to say here. So L into L plus 1 h cut square minus m square h cut square overall spherical harmonic. Okay. So this is your eigenvalue. See the D option, I guess. D is the correct answer here. Priyanka, did you get it?
Yes.
Okay.
Yes, yes,
So
yes.
I'll go to the next question. 17. A particle is moving in one dimension. X is equal to A to X is equal to B. That means instead of 0 to L, it is A to B. The potential energy is such that the particle cannot be outside. This is just like a particle in a box. The boundaries are A and B. and psi is given as a by x. Okay, so the average value of x. So how do you calculate average value? Psi star x psi dx, psi star psi dx, right? And this is a to b. You try to get, so psi star is again a by x. So here actually you are getting a square by x square into x dx, and below you are going to get a to b a square by x square dx. Where a square is constant outside the integral, it will cut. So ultimately you are going to get a by b 1 by x dx divided by a to b integral x to the power minus 2 means 1 by x square dx. So that is nothing but the upper part is ln x, your limits are a to b, and below is minus x to the power minus 1 b to a. You understand why I have written x to the power minus 1? Because x to the power minus 2 integral would be x to the power minus 2 plus 1 and whole divided by minus 1. So the formula of, I have just put x to the power n dx, which is x to the power n plus 1 by n plus 1, right? Instead of n I have put n is equal to minus 2. You just put the value, I guess you are going to get ln b by a, and below you are going to get 1 by a minus 1 by b, which is ab into b minus a ln b by a. So your C is going to be the correct answer. Just take a screenshot now. I'm just going quickly.
Yeah.
I'm going to the next question then. C.
Can this be the last one? Because I have to leave.
Yes.
Yes. Next one.
Yes.
Yeah.
So the 20. The probability of finding the electron between 0 to 2a naught for 1s of each atom. I hope you can solve it yourself, right? 20 and 21. Just take a screenshot, and if
Yes.
you can't, then we will discuss.
Just tell me the correct answer, so I'll
Okay.
know that.
So for the 20, the correct answer is B.
B.
See here, just one thing from here you can that we know the trick, right? See,
Yes.
one is
Yes.
your n is 1 here,
Yeah.
and there is no l
Z.
minus 0, no polynomial. That's why it's that. Then 21, the correct answer would have been, I guess, C, I guess. 20, no, 20B.
Okay.
Okay, 21 is B. 21, sorry, I am making it wrong. 21 is CF. I was correct. A1 is C. Okay.
Okay.
Here you need to do just get the value of x cube, means do the integration. Okay. Do the integration and take psi to be root over 2 by L sine n pi x by L, so that you don't have to normalize it, right? And the below portion you don't want to, denominator you don't have to do, only the numerator, and just put n to the n as infinity. Okay, so then you are going to get some value.
Okay.
Okay, and I have last these three questions. Take a screenshot. These are easy,
Yes, I'll take it.
and I hope you will be able to do these things.
Yeah.
Okay, then with that, today you took a screenshot.
Yes, I've taken.
So with that, it's good that I have some attendance on the last day.
Yeah.
For the last few days, no one came. I just
In
saw
total,
that.
how many students are there for the course? Because I joined twice and then I realized I was the only
No one is
one.
there. Yes, that is true. Total 300, maybe around 300 or 200, but no one is to join.
Okay.
So
Okay.
I just have to record the sessions and I put this thing in the YouTube.
Okay.
But in YouTube, the number of views is high. But I don't think a lot of people from NPTEL who have registered from NPTEL saw the videos because it was some statistics I got it something from the YouTube.
Okay.
But that's okay. If someone is getting help, then it's good. I
Yeah.
hope. Uh, so all the best for the exam.
Thank you.
The question will not be tough. Will be
Okay.
like this, but
Okay.
numerical questions will be there. A lot of numerical questions will be there. That is for sure. So have to have the skill of integration and all.
Hmm.
Not much.
Okay.
So
Just if you can give us like idea about the time given and
time I actually forgot.
the total marks.
Acha, that is not given in the mail. Maybe mail.
I'll check. Okay. Maybe I've missed out.
Yes. Let me check once.
Just the total marks and the time.
Let me check the assignments. It was there in the announcement section. Maybe I'll just check. Okay. Problems in the exam format. The type of exam will be available in the list. Let me check. Acha, list. Acha, you let me. This is quantum, right? Quantum chemistry of atoms and molecules. This is an online computer-based exam going to take place on 28th October. So you knew the date, right?
Yes. Yes.
Okay, so the exam date is 28th October and online.
Yes. The
And let me see if the where are the places. The hall ticket is yet to be released.
yes.
They will notify, and computer-based exam. The question will be on the computer. Answers will be have to entered on the computer. Type of questions may include multiple choice question, fill in the blanks, essay type answers. I don't think so,
Hmm.
uh, but still. And I think you need to carry your driving license and passports and other things. Hall center will be, I think, will be notified.
Okay.
Okay. Okay then.
Okay.
Thank you for joining.
Yeah. Thank you. Thank you
Yeah,
so much for your
welcome.
help. Yeah.
Okay.
Okay. Yeah.
Bye.
Okay. Bye. Bye.
Bye.